Hey guys, welcome to the new series, The Rise of Spatial Analytics in the Lakehouse Era. A beginner-friendly introduction to why location intelligence matter in a modern data platform like Databricks. Nowadays, customers are digital savvy. They are continuously doing some or the other digital activity, right from ordering the food, boarding a bus, driving a car, or walking into a store, or even you tag a photo in your social media. Everything carries a location. Think of it the way every row of data is a fact, and that fact happens somewhere. Yet, in most of the traditional analytic systems, where is an afterthought, it's stored as a column called latitude, longitude, or maybe an address, and then ignored. The reason it is ignored is it is very difficult to work with. There is no stand. There is a standardization, but on big data processing, there is no standardization. It requires GIS tools and that not everyone understands. It is too large and messy to scale. But today the world is swimming in geotag data, and we will be ignorant if we don't if we don't derive intelligence out of this location data. Mobile pings, delivery logs, custom check-ins, satellite feeds, IoT sensors. There are so many things which I can list down that we simply cannot ignore the location. If we want to unlock the full potential of data, location intelligence is must. So that's why this article is very important. It is going to be a series of around 11 articles in which in first 5 I am going to explain what is spatial intelligence to how Databricks is supporting spatial intelligence. We'll cover this in first 5 and then in rest of the 6 we'll try to take a end-to-end use case of 6 different industries which will help us to understand and actually will show the practical examples on the workspace how you can implement it. Okay, so let us start with what is spatial intelligence or spatial analytics. Spatial analytics means analyzing data that has a location component, data that tells us where something happened and how things move across space. Let's see some of the examples. Finding customer within the 5 km of a store, mapping mapping delivery routes and calculating the travel distance, overlaying property data on flood zones, grouping people by neighborhood and road network or by city block, tracking equipment or vehicle movement in a real time. So nowadays we also say that a lot of real time intelligence is coming. So real time plus location intelligence give you an absolute insight into what that entity is doing right then. Spatial analytics helps us go through tabular insight to contextual insight. It's like putting on the glasses and letting you see a new dimension of your data. See, many times we say that okay, there is a huge footfall of a customer within that 1 kilometer. That gives much more intelligence than okay, there is a festival and therefore there is a huge footfall in New York. Then saying that okay, within that 1 kilometer or within that 5 km of Times Square, there is a huge footfall. So displaying that ad in that particular time will be an amazing idea. So this is how the location intelligence matters. It's like putting the glasses that let you see a new dimension of data. But historically, spatial intelligence was trapped in GIS tools. Until recently, most spatial intelligence was stored in processed in GIS platforms like ArcGIS, QGIS, or specialized databases. The tools are very powerful, but they require specialized skills. You need to have an extreme specialized skills. They don't scale well on billions of records, don't connect easily with machine learning, streaming, or BI systems. They live outside the modern lakehouse pipelines. So data teams are stuck in like build a copy pipeline, take the data in. So there is always this processing time, and processing compute that gets wasted in this movement of data, like getting it here, converting into actual format. There will always be some or the other delay. Another shift has begun. The Lakehouse meets location. Why Databricks added Spatial SQL in 2024-2025? Databricks introduced a game-changing upgrade: native Spatial SQL data types like geometry and geography in Delta Lake. 80 plus built-in Spatial SQL function. No third-party libraries are needed. They are all available native. I have tried them out and I have built exercises out of that. So we'll cover that in the next videos. High speed spatial joins accelerated by Photon. Already Photon great guys present there. Grid indexing. There is S3 indexing is there. So this is kind of indexing on the data which helps you do location joins faster. Full compatibility with both batch and streaming workloads. As I said, if you are able to bring the data on Lakehouse natively functions available, building a real-time use case is not far. In short, spatial analytics is now available in plain SQL and Python inside Databricks. So no more geospatial hacks or GIS silos. The query finds every customer that lives inside store area. So we are having this query: select customer ID store name, where we are joining customer and store, and what we are doing is we are trying to use one of the function. This is just a sample I am showing, that whether that particular location of a customer is within the within the area of a store. If that is there, then definitely that is a proximate customer for us. That is a prospective customer for us. Okay, within the proximity, if he is present, that's a prospective customer for us. So this is how spatial intelligence are built. We'll go extremely detail into each and every part of it. Spatial analytics maturity model. So earlier, here is how teams grow in location analytics maturity. It's an amazing way to showcase how we can move the ladder of spatial analytics. So first, there is no spatial analytics, so always your analytics is not going to involve the location component. Okay, that will always be mapped out. The moment it is GIS enabled, we have to use some of the special databases called ArcGIS, QGIS, PostGIS, and they would help us to get that data. But the problem with that is you have to do that calculation in a specialized databases, then bring that data back into Lakehouse and then use that. So it takes some amount of compute, some amount of time to do that. Then we bring in big data plus GIS, right? Like data enhanced. So special ETL exists, but poor automation. As I said, if you start concentrating on bringing data in, back, definitely it makes the things complicated with lot of custom jobs around, and you have to maintain them. Okay, but if you are able to bring the spatial data, the spatial features onto Lakehouse itself, like you are having the geo data stored in Delta Lake itself, your spatial joins would be very happy. You would have to do everything natively within the Lakehouse, within Delta tables, and no need to build lot of custom jobs and lot of complicated things to monitor. Okay. And finally, as I already mentioned, if you have this thing natively available on Lakehouse, then real time is not far behind. So this is how you will you have moved to the ladder. If you are at the stage 4 where you are able to bring everything onto Lakehouse, the spatial intelligence onto the Lakehouse, then I think slowly, steadily you would be realistically moving to real time location intelligence as well. Databricks is helping teams jump directly from stage 2 to stage 4, and by making spatial feel like a regular data work. Real world use cases which we are going to check in a couple of couple of articles, a couple of article and videos. Let's try to understand. Like for example, uh, we'll go industry wise. So let's say you have a retail store. So a retail store always is a brick mortar store and is located somewhere. So let's say it is located at 13th Street in New York. Okay, so that store will always have a catchment area. A catchment area is in uh, the chances that if people are around, like let's say 3 kilometers or 5 kilometers, they could become a prospective customers. So that is called a catchment area. Maybe that's the best store within that area, right? So this is a use case where we can target this customer. We should avoid cannibalizing the customer zones. Fleets optimizing delivery routes using map data. Insurance, we can have a property data and then match it with the hazardous zones to ensure that if the things are matching, then the prices of the properties can be dropped. So the accuracy of data would improve. We can have an energy related use case where locating ideal land for solar and wind can be important thing. Smart cities, like monitor movement and IoT sensor patterns. In agriculture, we can have another set of a use case where analyzing crop stress from satellite grid. How are the crops doing? Those things can be analyzed. Okay. So having spatial data, as we always say, brings in the new dimension to the analysis. Spatial lakehouse architecture that we can build in is we can have raw spatial data coming into the lakehouse where bronze layer will store the raw files. Silver layer would clean and convert the data into geometry geography fields and apply indexes. Gold layer would have spatial joins, zonal aggregation and business models ready to be served to your AI agents, streaming alerts and dashboards. It's a clean, fast and scalable, and most importantly, everything done in the same platform, Lakehouse. Who is this series for? This video series is specially for the data engineers who are dealing with the spatial data pipelines, data scientists who eventually have to integrate this data with their machine learning models or AI agents, business analysts who are also uh, working in deriving business insights from the data, student or fresher who wanted to learn geospatial skills on a global scale platform, or the consultant or practice leader building a new location intelligence offerings. You don't need to know GIS tricks. You don't need to be cartographer. You just need to know the SQL, Python, and need to have the curiosity to build that out. What happens next? So let's go through it. We will be in next article we'll be understanding what is a geography and geometry feature for storing the spatial data. There are almost 80 plus spatial functions that are available. Then we'll try to understand how we can index these data to have a faster operations, and then build 6 to 7 different use cases on different industries, starting from retail, fleets, insurance, energy, smart cities, agriculture, everything, to take this location intelligence into an actual use case. Call to action is ready to bring special intelligence into your data engineering or AI projects. This is a series for you. So in next we'll be understanding the the concepts as well as codes, how this can be implemented. I have prepared specialized exercises where uh, we can you can see the actual code working out on how geometry geography data sets work, and how the data how that can be prepared, and how location intelligence can be derived out of it. Okay, so please do subscribe if you want to listen into the next set of videos. Please like the video. Thank you. Thanks for listening.